Good day everyone. Today we will be discussing the second type of variation, which is the inverse variation. When we say inverse variation, it is the relationship between two variables, x and y, that can be written as y is equal to k over x, where k is not equal to 0. And in inverse variation, we have the following statements that will serve as a clue whenever we solve a problem. Y varies inversely as x. It can also be y is inversely proportional to x. And from the equation of our inverse variation, y is equal to k over x. Your k here is the constant of variation that relates the two variables. Let's say our k is equal to 12. Now let us solve for the values of our y. Using the formula, we will substitute k, which is 12, and of course x, which is 2, 3, and 4. Let's compute. First, write the formula. Y is equal to, our k is 12, so divide it by your x, which is given 2. Our first y is equal to 6. So we need to plug in 6 on our table here. Next, y is equal to 12 as our k divided by x, which is 3. 12 divided by 3 is 4. So input on our table. Last but not the least, we have 12 divided by 4, which gives us 3. Now, as we analyze it, when our x increases 2, 3, 4, our y decreases. So this is an inverse variationship, 6, 4, and 3. Now to compute for the constant or the k, we can also use this formula. K is equal to xy. If we try to compute or we multiply x and y, for example, 2 times 6, our k is 12. 3 times 4, our k is 12. And then 4 times 3, still our k is 12. Next, you need to remember also the following class. Note, for two quantities with inverse variation, as one quantity increases, the other quantity decreases. Just like here on our table, when x increases, the y value decreases, or it can be vice versa. Now let us proceed with the following examples. Let us translate each statement into an equation. We will use k for the constant of variation. Okay, using the formula y is equal to kx, we will just substitute for the given variables. Z varies inversely as b. The answer will be z is equal to k as our constant of variation over b. That is for number 1. Number 2, m is inversely proportional to n. We have m is equal to k over n. Number 3, c is inversely proportional to s. We have c is inversely proportional to s. Next, the base b of a triangle varies inversely as its altitude h. We have our equation b is equal to k over h. So those are the answers for numbers 1 to 4 as we translate each statement into an equation, and we use k as the constant of variation. Now let's proceed with the 5 more examples involving the inverse variation. Number 5. The acceleration A of a car is inversely proportional to its mass m. A is inversely proportional to m. This is our answer for number 5. Next number. Given that y varies inversely as x, find the constant of variation if x is equal to 3 and y is equal to 7. So using the formula, just like what I discussed a while back, we have k is equal to xy. We will just substitute for the value of x and y in this equation. So k is equal to x is 3 and then y is 7. And our final answer here, our k or the constant of variation is equal to 21. Okay, number 7. If y varies inversely as x and y is equal to 10 when x is equal to 6, then what is y when x is equal to 15? In this problem, we need to use the inverse variation formula, which is y is equal to k over x. We will substitute for the values of y, which is 10, and the value of our x, which is 6, in this equation for us to get the constant of variation, which is the k. Given y is 10 is equal to, then we have k over your x is 6. So cross multiply our k here now will be 10 times 6 and then k. Perform the calculation. 10 times 6 is 60. That is our constant of variation. Since we got the k value, we can now proceed with the next problem. We need to compute for y when x is equal to 15. So using the formula y is equal to k over x, we will substitute for the value of k, which is 60. So we'll write y is equal to 60 over the value of x will be 15. So y now here is 60 divided by 15, 4. This will be our answers for number 7. K is 60 and then y is 4. Number 8. The width of a rectangular box varies inversely to its length. If the length is 12 meters and the width is 5 meters, find the constant of variation. Width is represented by the letter W. So this will be our equation. W is equal to inversely, meaning to say we will use this formula. So we have K as our constant of variation over the length. So we have, let's say the representation of length is L. Now substitute for the values of your width, which is 5 meters and your length, which is 12 meters, here in our equation. 5 is equal to k over the length is 12. So cross multiply, we have 5 times 12 is equal to k. 5 times 12 is 60. This is now our answer. 60 is our constant of variation. Last but not the least example. A wavelength of a radio wave varies inversely as its frequency f. A wave with a frequency of 1,200 kilohertz has a length of 300 meters. What is the length of a wave with a frequency of 800 kilohertz? First, just like what we are always doing, write the equation as our guide. But this time, based on the problem, we have this symbol for the wavelength. So wavelength is equal to k over your frequency or your f. Substitute for the value of your wavelength, which is 300 meters. So write 300 is equal to k over your frequency is given, which is 1,200 kilohertz. Cross multiply 300 times 1,200 is equal to k. So compute, let us find the product of these two. 360,000 is our k. Since we solved for our constant of variation, let us now compute for the length of wave with a frequency of 800 kilohertz. This formula will be used. Substitute for the value of k, which is 360,000 here, and the frequency will be 800 kilohertz. So we have wavelength is equal to 360,000 divided by 800. So the length of the wave, or our wavelength, is equal to 450 meters. This is now our final answer. You can compute it manually or you can use your calculator to compute easily. So that's it for the inverse variation. I hope you learned something for today. Thank you and God bless.